Doppler effect and different cases. We have to discuss the different cases of Doppler effect. Number 1, if the source of sound under bracket is moving towards a stationary listener, if the source of sound is moving towards the stationary listener under bracket L, in that case velocity of source that is Vs will be equal to Vs, and Vl is equal to 0 for stationary listener, and phi is equal to 0, that is Vs is equal to Vs, Vl will be equal to 0 and phi equal to 0. In the diagram, S is the source of sound, L is the listener, and actual frequency of sound wave is nu, and sound wave produced by the source S is moving with the velocity v towards the listener, and the source is also moving in the direction of sound wave towards the listener. As Vs is parallel to V, that's why phi is equal to 0 degree. Vs is the velocity of source which is moving in the direction of sound wave. Here L is the stationary listener. L is the stationary listener, that means listener is at rest. That's why VL is equal to 0, and apparent frequency heard by the listener is nu prime. Therefore, apparent frequency nu prime has the expression V minus 0 divided by V minus Vs into cos 0 degree bracket closed into nu, where nu is the actual frequency of sound wave. Therefore, nu prime will be equal to V divided by V minus VL, because cos 0 degree is 1 into nu. Nu is the actual frequency, and nu prime is equal to V divided by V minus Vs into nu, which is the apparent frequency of sound wave heard by the listener, provided the source is moving towards the stationary listener. Nu prime is the apparent frequency of sound heard by the listener. Therefore, source S is moving with the velocity Vs towards the stationary listener, and listener is at rest. That's why VL is equal to 0, and actual frequency nu prime will be equal to V minus Vs into nu. That is the apparent frequency of sound wave heard by the listener in terms of actual frequency nu, and in this case nu prime will be equal to nu, because nu prime has the expression V divided by V minus Vs into nu. After that, what we can write, nu prime is equal to V divided by V minus Vs into nu. That's why nu prime is greater than nu. That means apparent frequency of sound wave heard by the listener will be greater than the actual frequency of sound wave produced by the source of sound. Apparent frequency is greater than actual frequency of sound. Therefore, frequency of sound wave, the frequency of sound wave increases apparently when source of sound is moving towards the stationary listener. Here, frequency of sound wave increases apparently. Frequency of sound wave increases apparently when source of sound is moving towards the stationary listener. Again, we can write down the formula of apparent frequency: nu prime equal to V divided by V minus Vs into nu. Nu prime is equal to V divided by V minus Vs into nu. That is the apparent frequency of sound wave heard by the listener. This is the apparent frequency of sound wave heard by the listener, provided the source S is moving towards the stationary listener. If the source is moving away from the stationary listener, if the source under bracket S is moving away from a stationary listener under bracket L, stationary listener. In that case, the velocity of source, that is Vs, will be equal to Vs, and Vl is 0 and phi will be equal to 180 degree. Vs is equal to Vs, that is the velocity of source of sound. Vl equal to 0 means velocity of the listener is 0, and phi equal to 180 degree, where phi is the angle between the direction of motion of the source with respect to the sound wave which is propagating towards the stationary listener. Now source, this is the source, S is the source of sound, and we can denote the listener or stationary listener in this case. Source is emitting sound wave which propagates in the medium with the velocity v towards the stationary listener. Nu is the actual frequency of sound wave produced by the source, and here S is the source of sound which produces a sound wave, and in this case source is moving away with respect to stationary listener with the velocity Vs, and angle between the direction of motion of the source and direction of propagation of sound wave is phi, which is equal to 180 degree. Therefore, apparent frequency nu prime will have the expression v minus 0 divided by v minus Vs cos 180 degree bracket closed into actual frequency nu. Actual frequency nu. Therefore, nu prime will have the expression v divided by v minus v plus Vs, because v divided by v plus Vs into nu, here cos 180 degree is equal to minus 1. And here finally we get the expression of apparent frequency nu prime, which is equal to v divided by v plus Vs into nu. Nu prime is the apparent frequency of sound heard by the listener or heard by the stationary listener. Nu prime is equal to v divided by v plus Vs into nu, which is the apparent frequency of sound wave heard by the listener. And in this case, source is moving away from the stationary listener. Nu prime is the apparent frequency. Writing the expression again, nu prime is equal to v divided by v plus Vs bracket close into nu, where v is the velocity of sound wave and Vs is the velocity with which the source is moving away from the stationary listener. Nu prime is the apparent frequency. Nu prime is the apparent frequency of sound wave. Nu prime is the apparent frequency of sound wave heard by the stationary listener, where or provided the source of sound is moving away from the stationary listener. Here the listener is at rest and source is moving away from the listener. Provided the source of sound moves away from the stationary listener, and nu prime is, in this case, nu prime is less than nu. That means apparent frequency is less than the actual frequency. Hence, apparent frequency of sound heard by the listener, heard by the stationary listener, is less than the actual frequency of sound wave, less than actual frequency. Apparent frequency of sound heard by the stationary listener is less than the actual frequency of sound produced by the source which is moving away from the listener, produced by the source. Number 3 case, if the source under bracket A, if the source is at rest and the listener L is moving towards the stationary source, the source of sound under bracket s. In that case, velocity of source Vs will be equal to 0. Velocity of listener Vl will be equal to Vl, and theta will be equal to 180 degree. Theta is the angle between the direction of motion of the listener with respect to the direction of sound wave propagation. Vs is equal to 0 and theta will be equal to 180 degree. Now we can draw the diagram again. This is the source of sound which produces sound wave of frequency, actual frequency nu, and this is the listener which will be moving towards the source. Now source produces a sound wave which propagates along this direction with the velocity v. Nu is the actual frequency, and here this is the sound wave which propagates with the velocity v, and source is at rest, that's why Vs is equal to 0. Nu is the actual frequency. S is the source of sound. S is the source of sound, and that is stationary source of sound. L is the listener. L is the listener which will be moving towards the stationary source. Which will be moving towards the stationary source. Here the listener is moving with the velocity Vl towards the stationary source and in the opposite direction of propagation of sound wave. Here Vl, that means velocity of listener, is opposite to velocity of sound wave v. Vl is opposite to v, where v is the velocity of sound wave which propagates towards the listener. That's why theta is equal to 180 degree. Theta is the angle between the direction of listener and the sound wave propagation. Nu prime is the apparent frequency of sound heard by the listener. Nu prime is the apparent frequency of sound heard by the listener. Therefore, apparent frequency nu prime will have the expression V minus VL cos 180 degree divided by V minus 0 bracket closed into actual frequency nu. Therefore, nu prime will have the expression V plus VL divided by V into nu, where cos 180 degree is minus 1. Nu prime is equal to V plus VL divided by V into nu, that is the apparent frequency of sound heard by the listener, provided the listener is moving towards the stationary source. Nu prime is equal to V plus VL divided by V into nu, which is the apparent frequency of sound wave heard by the listener, provided the listener is moving, or the listener moves towards the stationary source of sound, Nu prime is equal to V plus VL divided by V into actual frequency nu, where nu prime is the apparent frequency, nu is the actual frequency. Therefore, nu prime is greater than nu. That means apparent frequency of sound wave heard by the listener. Apparent frequency of sound heard by the listener will be greater than the actual frequency nu of sound wave produced by the source of sound. Actual frequency of sound produced by the source of sound, or produced by the stationary source of sound. If the source is at rest, if the source under bracket is at rest, and the listener under bracket L is moving away from the stationary source, if the listener is moving away from the source, in that case the velocity of the source, that is Vs, will be equal to 0. Velocity of the source, that is Vs, will be equal to 0. Vs is equal to 0, and here Vs is the velocity of source of sound. Now velocity of listener VL will be equal to VL and theta will be equal to 0 degree, where theta is the angle between the direction of motion of the listener with respect to the direction of propagation of sound wave which is moving towards the listener. Now we can draw the diagram again. S is the source of sound. S is the source of sound and the source is at rest, and for stationary source Vs will be equal 0, that is velocity of the source will be equal to 0. Now we can denote or we can draw the listener. L is the listener and source is producing a sound wave which propagates towards the listener with the velocity v. This is the sound wave which is propagating towards the listener. Nu is the actual frequency of sound wave produced by the source. Listener L is moving with the velocity VL away with respect to the stationary listener. VL, in this case VL is parallel to V, that's why theta is equal to 0 degree. Velocity of listener VL is parallel to the velocity of sound wave V. That's why theta equal to 0 degree and nu prime is the apparent frequency. Here the apparent frequency nu prime will have the expression V minus VL cos 0 degree divided by V minus 0 into nu. Nu is the actual frequency. Or comma nu prime will have the expression V minus VL divided by V bracket closed into nu. Nu is the actual frequency of sound wave produced by the source. Therefore, nu prime is the apparent frequency. Nu prime is the apparent frequency of sound heard by the listener provided the listener is moving away from the stationary source. Nu prime is equal to V minus VL divided by V into nu, which is the apparent frequency of sound wave heard by the listener. Heard by the listener provided or where the listener is moving away, from the stationary source, under bracket S. So nu prime is equal to V minus VL divided by V into nu. That is the apparent frequency of sound heard by the listener provided the listener is moving away from the stationary source. Therefore, nu prime is less than nu. That means apparent frequency of sound heard by the listener. Apparent frequency of sound heard by the listener is less than the actual frequency of sound produced by the stationary source. Actual frequency of sound produced by the stationary source. In this case, frequency decreases apparently. That means when a listener is moving away from a stationary source, in that case, apparent frequency will be less than the actual frequency.